Okay, so in this lesson, we're going to be looking at section 11.4, normal distributions. So we're going to be looking at the graph of a normal probability distribution. We will explore how to use this graph to determine the probability that a measurement selected at random will fall within a specific interval. So the normal curve and its properties right here. This is a normal curve. It is symmetric. It's bell-shaped. The middle at the highest point is the average, the mean, mu. The curve is symmetric about this vertical line. The curve approaches the horizontal axis as the farther out we go, the closer it gets. So we have a horizontal asymptote at 0, y equals 0 right here on this horizontal line. The inflection points between basically what's cupped upwards, that's called concave up, and concave down, or cupped downward, okay, is the mean minus 1 standard deviation, or plus 1 standard deviation. The area under the entire curve is 1, because this is a probability distribution. It's also called a probability distribution, and so the highest probability you can get is 1. So what you see here is you see 1 standard deviation. This is where 2 is. This is where 3 and 4 and 5 and 6, and you just keep on going out as far and farther as you want. Okay, so this is what a normal curve looks like. From that, we can take the information and we can do and figure out how much lands in certain spots. And that's what the empirical rule is. You definitely want to know the empirical rule. Here's the empirical rule. For a normal distribution, approximately 68% of the data values fall within 1 standard deviation. 95% of the data falls within 2 standard deviations. And at 3 standard deviations, we're at 99.7% of all the data lands in there. Okay? So this curve, by the way, just so you know, when you are in college and stuff like that, and people say, are you going to grade on the curve? They mean something like this. Your response to that question is always should be no. You do not want to grade on a curve. And here's the reason why. Because it's all about how many data points there are. If I grade on the curve, 68% of all the scores have to land right here. And usually what they do is they call that a C. And this is a B, this is a D, this is the A, and this is the F. And it doesn't matter what score you got on the test, it's about how many data points and where they lie based off of the average. So if they grade it on a curve, if the average is a 90%, that's a C. Okay, and then the A would be the guy who got the highest scores and stuff like that. So you got to be careful about grading on the curve because it's symmetric and balanced. You want to just basically just take your percent. That's the best way to do it. But anyway, we can use this now. If 68% land within 1 standard deviation, you can see clearly that 34% are above the mean and 34% are below the mean in that 1 standard deviation. 1 above, 1 below. This is 2 standard deviations above. This grand total right here, you can see clearly is, since 95% is within 2 standard deviations, then it just did the value so you can figure out what percentage is in each little category here, little area. And so you use this to help you answer some questions and stuff like that. And so here's an example we're going to look at right now. All right, so I have the one I can write on right here. The yearly wheat yield per acre on a particular farm is normally distributed with a mean of 35 and a standard deviation of 8. So shade the area under the curve that represents the probability that an acre will yield between 19 and 35 bushels. So what they want you to do in that situation is they want you to draw a normal curve. And, you know, you can do like this, and then like this. This, in the middle, is the mean. And the mean is 35. So this is 35. And where would be in a standard deviation of 8, Okay, so one standard deviation in this direction, we're going to go between 19 and 35. So 19 is over here. So if I take 35 and subtract 8, then I get one standard deviation. This would be at 27 because 35 minus 8 is 27. And then if I take 8 from this, then I'm over here at 19. Okay? And so what they want you to tell me is, what is this area? And so if I know that I'm going between 19 and 35, and the standard deviation is 8, and I just found out that between 19 and 35, those are 2 standard deviations below the mean, then by the empirical rule, I know the probabilities there. Okay? I know the area under this curve. This is a 34. Okay? And this over here is 13.5. So together, okay, together you add those together and you get your final answer. All right? So is the area the same as between that and 2 standard deviations? And the answer is yes. We just discussed that. So the answer is yes. Use the empirical rule to find the percentages. This is what we were just in the process of doing. Okay, so that is 13.5 plus 34, and we get a probability or an area of 47.5%. So as a percent, we can consider that to be a probability. You can also change it down to because we want to be a number less than 1. This is a percent. This is not a number, it's a percent. So if 47% of the total area is in that region, then my probability is 0.475. So that would be the probability. So that's kind of how it works. It goes from this is why it's called a probability distribution or a normal distribution or a normal probability distribution. So the area is the probability, is how it works out. For this one right here, we can show that it's the same by simply plugging into this formula. Mu minus 2 sigma is 35 minus 2 times 8. And you work that out and you get the 19. So that's the work that you can show from that one. Okay? The next thing after this is to help us find these numbers, because if it's not nice and neat, if it doesn't land exactly on a standard deviation, okay, then we can have some issue here. So normal distributions vary from one another because of the mean. Mean can be anywhere along the x-axis, and the bell shape can be more or less spread according to the size of the standard deviation. It's impossible to try and set up a table of areas under a normal curve for every different mu and sigma combination. Okay? And it's difficult to compare values from different probability distributions. How do I compare things of different types? So they fixed this by going and changing everything to a standardized normal distribution. So they modify this in just a fashion. It's still the same kind of idea. It's just we're looking at it a little bit differently. A normal distribution is based on how many standard deviations a measurement lies from the mean, okay, with the mean equal to 0 and the standard deviation is 1. This is your standardized, okay? So if I take any other normal distribution, I can convert it to this distribution, and you can see, if you look closely here, you can see that it's still 1 standard deviation, still the 68, 2 standard deviations, still 95, and 3 is still 99.7. So how do I do this? Any normal distribution can be converted to a standard normal distribution by converting all the measurements to a standard z-score. And we can use this to compare a value in one distribution to a value in another one. A z-score is a number that represents the number of standard deviations between the original measurement and the mean. So a z-score, what we do is we don't look at the actual values of the items and compare it to the mean of that data set. What we do is we convert it to a distance, okay? how many standard deviations is that item from its mean? That is what a z-score is. Okay? Z-score is close to 0, tells us that the measurement is close to the mean. Positive scores tell us the measurement is above the mean. Negative scores mean it's below the mean. Here is the formula for finding a z value or z-score. This is the entry, okay, the element or the entry in your data set. This is the mean of that data set, and this is the standard deviation of that data set. If you do this formula, you'll get the z-score, which is how many standard deviations a number is from the mean. Okay? So, once we have that, we're now going to learn how to use that to our advantage. So here is the next example. Rod figures that it takes an average of 17 minutes with a standard deviation of 3 minutes to drive from home, park the car, and walk to an early morning class. One day it took Rod 21 minutes to get to class. How many standard deviations from the average is this? And then the next questions are, is the z-score a positive or negative? Explain why it should be positive or negative. So how do I know that it is? Okay. So part A, and then we'll do part B here in just a moment. So let's look at part A. All right. So I'll write it down here. Part A. So if 21, you want to know how many standard deviations that is from the average, we're going to use our z-score formula. Again, which is the number I'm going to use, the average, and the standard deviation. So this will be 21. The mean is 17, and the standard deviations is 3. Okay? And so we take this, we're going to round this off to 2 decimal places, and this becomes approximately 1.33. Now, why do I need to do this? Well, 2 decimal places is because you're going to be using a table that's going to help us find probabilities, and it's only 2 decimal places. All right? So there's my z-score associated with the number 21. So how many standard deviations is 21 from its mean? It is 1.33 standard deviations from its mean. The z-score is positive. Okay, so the z-score is positive because why? Well, because the number I'm looking at is greater than the mean. Because the time value is greater than the mean of 17. So the time value 21 is greater than the mean of 17, so it should be a positive value. Okay, what about part B? What commuting time corresponds to a standard score of negative 2.5? Okay, could he count on making it to class in this amount of time or less? Okay, so the first thing is what they're doing here is they're actually going the reverse. So I give you the z-score. So the value that we're going to be looking for, the commuting time, is a negative 2.5 standard deviations from the mean. So we need to use the formula and convert it back. So in this case, using the same formula here, z, which is a negative 2.5, is the number I'm looking for minus the mean divided by the standard deviation. So you just solve for x in here, and when you get done, you'll get x is equal to a negative 2.5 times 3 plus 17, and you'll get a number of 9.5 minutes. Okay? And so the question is, could we count on him making it to class in that amount of time? And, well, what does that mean? That means that you are basically 2.5 standard deviations away from the mean, which means you're way over here. Okay? What are the chances that you're able to get to this one? Knowing that 95% of all times are going to be between these two, That's where negative 2.5 is. Okay? Very small chance of you being able to make it in that time frame. So I would say, in this case, no, that commute times at or less than 2.5 standard deviations below the mean are extremely rare. Okay? Not likely to happen. All right? So the next question then is this one right here. We're going to use a table of values for the area of standard normal distributions to find the area under the curve when z is a negative 1 and when z is 1.18. So how does this work? Well, let's start off by drawing a little picture of what this means. Okay? So we're kind of using this template right here. Okay? 0 is here. And what you're going to do is you're going to draw a line approximately where you think the z number is at. So a z number of a negative 1.00 would be right here at this line right there. So what we're going to do is we're going to draw this picture to represent it. And I always recommend that you do this. It doesn't have to be pretty. Just draw a little bell curve right here. Here is my mean. This is mu. This is at 0. Okay. If that is at 0, then where is a negative 1? Negative 1 is over here. Negative 1, just draw a little line representing it. And the way this works is, just like we did for percentiles, where everything's to the left. So when I draw this line right here, what I'm looking for is this area right here. Always the area to the left of your number. Very important to remember. You're always doing the area to the left of the z-score. Okay? When you have a z-score number, that's what it means. Now, what is this table we're talking about? The table we're talking about is this one right here I gave you. This is the areas for the standard normal distribution. This is when the z-score is below the mean, and then this one is when the z-score is above the mean. Notice the shaded region is always to the left of the z-score. So our z-score is negative 1 below. Okay, so I come over here, and here's how the table works. You look for this number. This one takes you the whole number and the tens place. And then this number across is the hundredths place. So a negative 1.00, I'm looking for a negative 1.0 and then 0. 1.00. If it was 1.01, then I would go to this column. 1.07 would be over here. Okay, so 1.00 is this one, and so that is the number I want right there, 0.1587. And so what is the area under the standard normal curve to the left of that? It is 0.1587. That's how that works. Remember, the entire area is 1, so all the numbers will be less. This is also basically the probability. What is the probability that I would have an entry in this area over here? That much. Okay? What is the area to the left of z equals 1.18? Well, that's a positive number, so again, let's draw the picture. The picture helps tremendously. I recommend highly that you draw it. It doesn't have to be pretty. It just has to be drawn. And so this line right here represents 1.18. And that means I'm looking for this area here because areas are always to the left. You can see that you're going to get a number bigger than 50 because this is the middle. And this is 0.5, that's half. And so we got to figure out this part right here. So we go to our table. Now we're going to go to the other one for z-scores above the mean. 1.18. So 1.18 is 1.1. Find 1.1 right there. And then 8. 1.18. So follow this along. And you get that number right there. 0.8810. So this is 0.8810. And that is the area to the left of that Z. That is how the table works. Okay, and I do recommend highly again that you draw these little pictures if you're going to be doing this, because they do get kind of interesting. Let's take a look at some of the ones that are going to be doing, and to help us out, here's a little chart down here. I know the words are kind of hard to see, but basically I'll zoom in here so for those who are taking notes at home can kind of see it. Area to the left. What if I want to find the area to the right? If I want to find the area to the right over here, then it's the whole area, which is a 1, minus the area to the left. So that's how you get areas to the right. Okay. This one's kind of interesting. Be careful of this one because it's symmetric. We can kind of help ourselves out. I don't like this one too much. I like this approach better. It makes more, you're not going to make any kind of sign errors. What if I want to find the area in between two z-scores? Then you take the upper one, find the area to the left of the upper one, and then subtract the area to the left of the lower one. So that's how you can find different pieces of things. Okay? Let's go do some more. All right, so here's an example we're going to do. We're going to find the area between 1 and 2.7. So again, if we draw our picture for this, if I draw this picture, you can't see it. Let me zoom back out again. So we draw our bell curve like this. What area am I looking for? Here is the 0. I want 1 and 2.7. So here is the 1, and here is the 2.70. So I want that area here. So I can see that I'm doing an area in between. So if I'm doing the area in between, I want to find the area. I want the area to the left of 2.70, and then I'm going to subtract the area to the left of 1. That's what I'm doing. We go find the area for 2.70. 2.7, and then 0 would be right here. So 9965, 0.9965, 0.9965, and then area to the left of 1. So 1.00 is 0.8413. 0.8413, and then you work this out and you get your answer, which is 0.1552. So that is the area between the two. Okay, and then this example was going to the right of our z. So again, draw a little picture. Here is the 0. 0.94 is the number above. So 0.94. I want this area over here, so I know I'm going to the right. To do that, I'm going to take the area under the entire curve and subtract the area to the left of 0.94. Well, the area of the entire curve is 1. And what is the area between to the left of 0.94? 0.94 is 8264. 8264. 8264. So the area to the right is going to be 0.1736. And so that's how you would do that. Okay? All right. Let's continue. Here's a note. The probability that z lies in an interval is given by the area under the standard curve, normal curve. Well, that's what we just talked about. So when they talk about probabilities or area of the curve and probability is the same thing. So when I do this chart over here, Not only are these the areas under the standard normal curve, but they're also the probability of that happening. Okay, so it's the same thing. So down here, we have some examples to do again. Let's pull this over. So let X have a normal distribution where mu is, or the mean is 10, the standard deviation is 2. Find the probability that a value selected at random from this distribution is between 11 and 14. So what is the probability that some X value in my distribution is between 11 and 14? So to do this, what we want to do, okay, so what this is saying here is, in its normal distribution, I have some normal distribution for this data set. This right here is the mean. This is 10. Standard deviations of 2, okay? So if this is 10, 11, 12, 13, 14, this is 11, 12, 13, 14. I want to have basically between here and here. I want to find that area, that probability. Well, this only works for a standard normal distribution. This is just a normal distribution, so we will need to standardize it. To standardize it, you need to find the z-score associated with 11 and 14. Okay, so what is the z-score? The first z-score is going to be 11 minus the average divided by the standard deviation. So you work this out, you're going to get 1/2, which would be 0.50. Then we want to find the second z-score for the 14, and we get 2.00. What this means is I now have converted this to a standardized normal distribution where that is now 0. Okay? And now I want to find the area between 0.50 and 2.00. I'm looking for that area. In other words, the probability that X is between 11 and 14 is the same thing as the probability that the z-score is between 0.50 and 2.00. So how do I do this? I want to find the probability that the z-score is less than 2 minus the probability that the z-score, the probability is less than 0.5. So that one minus that one gives me what's left over. We go to our table, we look these up, and when we do, we'll get this to be 0.9772. This is 0.6915. And when you subtract them, you're going to get 0.2857. And that is the probability that the X will land between 11 and 14. Okay? Here's another example we can follow. The lifespan of a rechargeable battery is the time before the battery must be replaced because it no longer holds a charge. One tablet model has a battery with a lifespan that is normally distributed with a mean of 2.3 years and a standard deviation of 0.4. What is the probability that the battery will have to be replaced during the guaranteed period of 2 years? Okay. So if I let X represent the battery lifespan, then this statement here, I want it to be, what's the probability it's going to be replaced within the 2-year guaranteed period, basically means what's the probability that X is going to be between, be less than 2. So that's what I'm looking for. Okay. So if the lifespan is below 2, then that's this. So what is that probability? Well, I need to take this and convert it to a z-score. Okay. So it is 2 minus 2.3, which is the mean, divided by 0.04, which is the standard deviation. And you use your calculator, you're going to get negative 0.75. So this means that the probability that the battery will have a life expectancy less than 2 years is equivalent to the probability that the z-score is going to land be less than a negative 0.75. In my picture for the z-score, a negative, that is right over here. This is a negative 0.75 standard deviation, so I'm looking for that area, which is to the left. So we can just go straight to our table, which you all know how to do. I'm not going to walk you through that one again. And you're going to get 0.2266. Okay, so what does this mean? In context of this problem, you want to identify and determine what that means. Okay, this means that the company will replace about 23% of the batteries in the guarantee period. I give us guarantee. Guarantee period. Okay? That's what it means. All right. Some other questions here then that help us out find z-scores and x values and stuff like that would be this table right here. Again, I'll zoom in a bit because the wording is kind of small. Okay. In this particular case, what you're going to be doing is looking for, I'm going to give a probability that something's going to happen, and you got to tell me the z-score or the data entry value that creates it. Okay. And so you take a look at that right there, and you can see you can make write those down so you understand how to find those things. Okay. You can pause right here to write all that out. And let's move on to the next example that we're going to be looking at. So here's the next example. Let's find a z-score such that 3% of the area under the standard normal curve lies to the right of z. This is why you want to draw a picture. Here's the standard normal curve. This is 0. I want 3% of the area to be to the right of z. So there is some z over here where this area to the right of it is 3%. Okay? Now, to do this, there is no value to the right on my table, okay? Only to the left. So if this is 3% this way, then the z-score on the table will correspond to these thing over here, which is the 97% over here. So that's what we're looking for. So the area to the left, or the area, to get this area right here, it's the whole area. Okay, the area is going to be 1. So it's basically going to be 1 minus 0.3, which is the 97%. That's how we got that. And so we go over here and we look. 97% is 0.9700. We go over here and look for 0.9700. We look into the field of numbers. Find 9.97. Get as close as you can, either above or below. You literally want to be the closest you can possibly get. 9.7. So find the 9 sevens. Okay, here's the 9.7. So this is 0.9706. So it's 6. This is, 6 10,000, tens, hundreds, thousands, 10,000ths away. But this one is only 1 10,000th away. So even though this is below it, it is still the closest right here. So we're going to use that value right there. And we want to find the z-score associated with it, which is 1.88. So 1.88. Let me see if I can get it all on the page. Okay, 1.88. So that's what corresponds to the z-score here. So the z-score is going to be 1.88. Okay, find the z-score that's such at 3% over there. There. Okay. B, suppose the time to complete a test is normally distributed with an average of 40 minutes and a standard deviation of 5 minutes. After how many minutes can we expect all but 3% of the test to be completed? Okay, so in this particular case right here, you can see it piggybacks off the question above. We want all but 3%. In other words, there's 3% left. So that means 97% have been completed. Okay, so we're going to look for the x value such that 3% of the normal distribution lies to the right of x. We found in this part right here that the z-score associated with that is 1.88. So my z-score is my value minus the mean divided by the standard deviation. Okay, plug in what we know. So 1.88 is the z-score. We're looking for the x. The mean is 40. The standard deviation is 5. Solve this for x. 1.88 times 5 plus 40. And we're going to get 49.4 minutes. So what is this? Oops, sorry. So what does this mean in context? So all but 3% of the test will be completed in about 15 minutes. And you can round that up to the nearest minute. And so that is how you can do a question like that. Okay, so we'll be doing more of these together in class in your homework areas. So if you have any questions, please make sure you ask.